Today, our chapter is Legendre's function. Legendre's function. At first, we know the Legendre's equation. The differential equation 1 minus x square d2y by dx square minus 2x dy dx plus n into n plus 1 into y equal 0 is called, this equation 1 is called Legendre's equation. Legendre's equation. Let the solution of the equation is descending power of x, y equal x to the power m a0 x to the power minus a0 sorry a0 plus a1 x to the power minus 1 plus a2 x to the power minus 2 plus dot dot dot, or y equal summation r equal 0 to infinity ar x to the power m minus r. Again we write y equal summation r equal 0 to infinity ar x to the power a minus r. Now differentiate with respect to x, we get summation r equal 0 to infinity ar x to the power m minus ar m minus r x to the power m minus r minus 1, and again differentiate, we get summation r equal 0 to infinity ar m minus r minus 1 x to the power m minus r minus 2. Putting the value of y dy dx and d2y by dx in the Legendre's equation, we get what we get? We get if we write the equation again, d2y by dx square plus minus 2x dy dx plus n into n plus 1 y is 0. Simplified it, d2y by d2x square minus x square d2y by dx square minus 2x dy dx plus n into n plus 1 y equal 0. Now put all these values, summation r equal 0 to infinity ar m minus r minus 1 x to the power m minus r minus 2 x to the m minus r minus 2 minus x square summation r equal 0 to infinity equal 0 to infinity ar m minus r minus 1 x to the power a minus r minus 2 minus 2x into summation r equal to 0 to infinity er minus r x to the power a minus r minus 1 plus a into n plus 1 summation 1 plus 0 to infinity er x to the power a minus r equal 0. Now rearranging this, this all stuff we get, what we get? Finally we get summation r equal 0 to infinity third bracket a minus r minus 1 x to the power a minus r minus 2 plus second bracket n into n plus 1 minus a minus r minus 1 minus r plus 1 second bracket complete x to the power a minus r x to the power a minus r third bracket close here equal 0. Now the second summation now equating to 0 of the second summation we get second summation means n into n plus 1 minus a minus r into a minus r plus 1. This is equal to 0. We get plus minus r minus r plus 1 to 0 n square plus n minus minus r minus r plus 1 equal 0. For r equal 0, this is n square plus n minus m into m plus 1 is 0. M square plus n minus m square minus n equal 0. M square minus m square plus n minus m equal 0. N plus n minus m plus n minus n equal 0. N minus if we common n minus m, then n plus n, then remain n plus n plus n equal 0. What we get? We get n minus n equal 0 and n plus n plus n equal 0 plus n equal 0. Then n equal n and n equal minus n minus 1. Next, we equating the coefficient of x minus 1. Coefficient of x minus 1 to 0. Equating the coefficient of x minus 1 to 0. Next, we equating next we equating the coefficient getting the coefficient of x to the power a minus 1 to 0 when r equal 1 get u1 n into n plus 1 minus e minus 1 into n equal 0 and u1 equal 0. u1 equal 0. Since m equal minus n minus 1, then this cannot be 0 because m equal minus n minus 1 and this is we get a value but u1 equal 0. Now we equating the coefficient of x to the power n minus r minus 2 to 0 to get e minus r minus e minus r e minus r minus 1 into ar plus n into n plus 1 minus m minus r minus 2 m minus r minus 1 into ar plus 2 into ar plus 2 equal 0. Now this n into n plus 1 minus m minus r minus 2 m minus r minus 1 equal minus m minus r minus 1 minus 1 m minus r minus 1 minus m into n plus 1. Let's clear it. Minus m minus r minus 1 whole square minus m minus r minus 1 minus n into n plus 1 n square minus n minus n minus r minus 1 whole square minus n square. This is the formula of a square minus b square minus n minus r minus 1 plus n. It means that means minus e minus r plus e minus 1 a minus r minus n minus 2. If we calculate it, we get a minus r plus n minus 1 into a minus r minus n minus 2. Put this value in the above equation. We get a minus r minus r minus 1 minus a minus r plus n minus 1 into a minus r minus n minus 2 into ar plus 2 equal 0. Then the value of ar plus 2 equal, here is a ar, sorry, there is a ar. Here value, then the value of ar plus 2 equal a minus r minus r minus 1 into ar divided by minus r minus n minus 2 plus 2. Since a1 equal a3 equal a7 equal 0 equal 0. Now for case 1, when m equal n, m equal n, we get ar plus 2, then we get ar plus 2 equal a minus r a minus r minus 1 divided by a minus r plus n minus 1 a minus r minus n minus 2 into ar. If r equal 0, then a2 equal a into a minus 1 a0 divided by n plus n minus 1 into n minus n minus 2, and e4 equal e4 equal, sorry, here m equal n, then n into n minus 1 ar 2 n minus 1 minus 2 equal minus of n into n minus 1 ar divided by n minus 1 into 2 into 2. This is the value of a2. Now if r equal 2, then a4 equal n minus 2 n minus 3 a2 divided by 2 n minus 3 into 4. If we put the value of a2, then we get a4 equal n minus, then we get a4 equal n into n minus 1 into n minus 2 into n minus 3 a0, sorry, here is a0, a0, 2n minus 3 into 2 into 4. Sorry. Now we get the one of the value of the Legendre's differential equation. Y equal a0 into x to the power n minus first a2 n minus n into n minus 1 y 2n minus 3 into 2 plus now a4 n into n minus 1 y minus 2 n minus 3 divided by 2n minus 3 into 2 into 4 into 4 minus dot. This is the one of the value of the one of the solution of the Legendre equation. Y equal a0 into this. Now, if for case 2, now for case 2, if m equal minus in minus 1, then ar plus 2 equal n plus r plus 1 into n plus r plus 2 divided by r plus 2 into 2n plus r plus 3 into ar. If similarly, if r equal 0, similarly for case 1, if r equal 0, then a2 equal n plus 1 n plus 2 divided by 2 into 2n plus 3 into a0. And if r equal 2, then a4 equal n plus 3 n plus 4 4 into divided by 4 into 2n plus 5 into a2. If we put the value of a2, then we get a4 equal then we get a4 equal n plus 1, sorry, then we get a4 equal n plus 1 n plus 2 n plus 3 n plus 4 into a0 divided by 2 into 4 into 2n plus 5 2n plus 3 into 2n plus 5. Now we get the another solution of the Legendre's equation. Y equal a0 into x to the power n plus n plus 1 value of a2 n plus 1 n plus 2 divided by 2 into 2n plus 3 plus value of a4 n plus 1 n plus 2 n plus 3 n plus 4 divided by 2 into 4 into sorry 24 into 2n plus 3 into 2n plus 5 plus dot. This is the solution of Legendre's equation.